1990, and also some expansion in the last 25 years. Well, these two cities are really different because Chicago is almost 5 times bigger than Ho Chi Minh, but it has 30% less people, so quite different cities. And here also the evolution, so the geospatial patterns of change of the population and built up in these two cities, with Ho Chi Minh that has increased by a factor of 6 this population, and only a factor of 3 that it's built up, while in Chicago the population almost didn't change in the last 40 years, but the built up doubled. Another indicator that we were able to build with these 2 layers is that one that maps inequalities across the globe at 10 kilometers by combining our population and built-up layers with night lights. We basically do a very simple thing. We have three values: light, population, and built-up, and we use a color coding by assigning the red color to population, the green color to built, and the blue color to light. And with this, yeah, it's not basically the best light for this map, but given this indicator, you can easily find different patterns of inequalities across the globe, with the Sub-Saharan Africa that is basically red, so a lot of population, few built up and a few light. The Europe that is blue and green, so it means that there is a lot of light and a lot of built up with few population. And the Indian and China area that is changing from red to yellow, so a lot of population and sometimes also a lot of built up, basically in the area of Beijing. Here is a zoom in Central Africa, where you can see also in the Middle East that it's very blue area here. That means a lot of light. And this is basically due, most of this to oil extraction. So the oil extraction platforms are really lighted for security reasons. There's no population and there is built up, and this is why they show blue in the map. While here you have the contrast of Africa that is basically red. And this is all reported in our technical report on detecting spatial patterns of inequalities that is freely downloadable from the JRC portal or the Science Hub of the European Commission. We also produce, as I told you, I work in the disaster risk management, so our aim is to produce exposure layers, so built up in population, in order to analyze the exposure of these two things to different earthquakes. And this is an example of of indicators that we produce with the changes of population for different hazard in the exposed area across the different epochs, easily by combining the layers of population and built up with the hazard map. But going back to urban, to the third product we produced, so it was the settlement layer. So how did we define the different settlements? This is a thing that started in 2016, the Habitat 3, and we aim to produce a global harmonized definition of cities. Why? If you are producing indicators for 2 different cities, like what we saw for Ho Chi Minh and for Chicago, if your definition of cities is completely different. Basically, if you have a city that is mostly unpopulated, but it's really relevant for your nation, so for the country, that is a city, and then you have another city that is defined a city because it has more than 100,000 people. These are 2 different things, but still you consider both cities, and if you produce an indicator for these 2, probably these 2 things are not comparable. So the idea is to produce an harmonized definition of cities that has been presented and discussed at the UN Statistical Commission this June, and probably will be adopted by the UN Statistical Commission next March. Basically, the idea is to define where does a city stop, how you can have an harmonized definition. Basically, if you look at the national definition that are included of cities that are included in the World Urbanization Prospect, each country has several definitions of cities that are based on population, that are based on services, that are based on, let's say, the historical value of some areas. Our idea is very simple, it's just to define a city according to the population size and population density, and sometimes built up. This is avoid the link with problems, because a lot of areas are defined as cities or rural areas according to problems. So access to water, access to energy. But if you define things according to problems, then if you don't have problems, you are missing that area. For example, if you are rural, if you have a city that is defined that if you have at least 50% of population with access to water, then you provide the water, then you don't have any more rural areas. And then, so it's not basically a good way to define a city. The problems should be found within cities that do not have access to water. So you define a city, if there is not access to water or to energy, then you can act, you know that you can act on that area. So here, well, I don't go into the details. Here is the definition of our settlement model that defines basically 3 classes based on the population density at 1 kilometer and the size of the cluster of pixels at 1 kilometer. So it should be an area with at least 50,000 people. Then you have the towns and suburbs that make part of the urban cluster. So pixel with at least 300 people and with a total population of at least 5,000 people, and then all the rest is rural. With a more, let's say, hierarchical definition that expand these 2 classes in dense urban and semi-dense urban that are towns, basically, and the suburbs and periurban area here, and or the villages and other areas, still based on threshold only on population size, built up, and population density. Applying these rules in combination of our built-up layer and population layer, if we go back to our Bangkok, here is what we have with the main core of the city that is this big red blob with some satellite cities in the surroundings, many small towns in light and dark brown here and there, and all the yellow that is the suburb, and then the green area that is the rural area. Given this layer and all the others, we were able to define the share of urban population and compare these values with the values provided by the UN DESA in their World Urbanization Prospect. And you can see that we are basically aligned in Europe and North and South America, while we have big differences in Asia and Africa. This is due to basically what I was saying before. Here, the definitions are usually including the access to energy or the access to water and other services. Starting from these layers, one methodology that we developed, we didn't produce actually the indicators values for all the cities, but the methodology is available and you can have a look by downloading this report. Here's the analysis within the urban centers of net and gross growth, both of built up and population. So here an example of New York. We have in a dark red the area of New York in 1990, and in the light red, all the expansion areas between 1990 and 2015. Given these 2 things, we were able to see that the total increase of built up in New York was between 1990 and 2015 was due by 37% of increase of infill, so built up that it was newly built within the boundary of the stable city between the two epochs, while the 73% was due to built up of area in dynamics areas, so the areas that were not urban before. And 38% was already built, and 25% is new built up, built in those areas. Same for population, where we have 50% of population growth, that is a net population growth within the stable core of the city, while the rest is basically due to population that was already present in the dynamic areas that were included, and only 5% is due to increase of population in such areas. Another methodology that we developed, and still also we are now working a bit with this, but you can download this report where the methodology is described and you can apply it using the raster layers, is the analysis of urbanization dynamics. Basically, we define the demographic factors of change in urbanization. So given the change between two epochs of rural population and urban population, you can easily define 8 different cases of urbanization dynamics. So here you have this diagonal that define if the population is increasing, total population is increasing, and below the population is decreasing. Here this line defines your current level of urbanization. If your variation of rural and urban population falls here, you are basically an urban-driven urbanization and demographic growth. So you are an area that increases the urbanization with an increase of population. And for example, if you fall here, it means that you have a reduction of rural population and an increase of urban population with a total reduction of population. So you are an urban resilient urbanization and demographic decline. All these can be defined given an area of interest that you can use, so an administrative unit, a region, or a total country. So I presented you these 3 layers and some of the analysis that we did. And now we just briefly talk about the latest one, that is the urban center database. Basically, starting from the settlement model, we define the urban centers. And given the boundaries of these urban centers, so the cities, we were able, by adding other sources, to define some indicators for each city. For each city, we analyzed several things, and we attached several attributes of geography, so basically where it's located, in the river basin, the name, the elevation, travel time to the capital, some environmental indicators about the climate, the temperature variation since 1990 to 2015, the CO2 concentration, CO2 emission, PM2 emission and concentration, some indicators of exposure, of course, and some socioeconomic indicators about population, built up, GDP, and development indicators. But mostly we were able to compute 2 SDG in the SDG 11 using the multi-temporal information of this data set. We compute the land use efficiency and all access to green spaces, basically. You can access to this database from our web portal, but I will go back again to our portal later. Using this, in this data set, you have more than 10,000 cities that are defined across the globe. And this is a big achievement because currently the benchmark